Just want to say good afternoon, everyone, and welcome to our session today on adoption of robotics for SMEs, our innovation roundtable. I'm Freddie Nanielu, and it's my pleasure to welcome you all to today's session, where we'll be exploring how small and medium-sized enterprises can successfully embrace robotics to drive productivity, resilience, and growth. We know that across the UK, robotics and automation are no longer future ambitions. They are practical tools that forward-thinking businesses, which I hope we all are already deploying to solve real-world challenges. But for many SMEs, that journey from initial interest to actual adoption can feel complex, costly, and uncertain because we don't often have enough information to make the right choices. So today, I hope that we'll be cutting through some of that noise, hopefully sharing some real world experience of what's going on, especially here in our region, and giving you greater clarity and confidence to take the next steps. So, and we're fortunate to be joined by an excellent panel of exceptional experts who bring deep industry insight and hands-on experience. So we have Ian Pulford, who's a director of Smart City Consulting, Dr. Gilbert Tang, Senior Lecturer in Robotics at Cranfield University, and Andrew Brock, Senior Advisor in Automation Transformation at the Manufacturing Technology Center. And each of them brings unique perspective on what works, what doesn't, and how SMEs can adopt robotics in a way that is sustainable, scalable, and aligned with business goals. So thank you once again for joining us, and I look forward to having an engaging and practical conversation with you all. I'll now hand over to our host for the event, Professor Ben Allen. Ben, over to you.
Thank you, Freddie. Good afternoon, everybody. Just extend my welcome as well, and to give you a broad outline of the remainder of this 1 hour, and we will endeavour to make it no more than 1 hour because that has ramifications and impacts here and there. But that's a nice introduction, and we have 3 speakers, and without further ado, I believe that it will be, is it Gilbert that's going to speak for a few moments, and then Ian, and then Andrew, if I have the order correct.
I think we were going to kick off with myself first, actually.
Oh, then that's fine,
Yeah.
No problem. And so after our 3 speakers have had a few moments to introduce themselves and their topics, we'll have the remainder of the time for question and answers, with the exception of perhaps about the last 5 minutes or so when we can make a summary and Freddie might want to have a few words at the end. So yes, please go for it.
Okay, that should be shared now. Can you see the, oh, you've got the notes slide there, haven't you? Let me try again. That's the one. Okay, can everybody see the presentation? Quick introduction. I'm Andrew Brock. I'm from the MTC, which are part government funded, part from industry and part from the Catapult. And we're really here as a technology advisory and help service really for British industry. So if you haven't heard from us, look us up. Okay. So in this presentation, there are 3 themes that will be unpacked. We've got barriers to adoption, catalysts for change, and investment timing. These themes serve as a roadmap to help SME leaders, operational managers, and technical staff understand the evolution of automation readiness. Examples such as typical concerns about upfront capital expenditure, the lack of in-house robotics expertise, and uncertainty about integration complexity demonstrate the need for foundational clarity before exploring just clear a window before exploring practical solutions. Additionally, the introduction frames the relevance of new models such as leasing and robots as a service, which are lowering traditional financial hurdles. Small and medium-sized enterprises in the UK face a set of persistent operational challenges that make achieving productivity and consistency difficult. Tight operating margins mean that any disruption or inefficiency directly affects profitability, especially for manufacturers operating in competitive supply chains. Skills shortages, particularly in technical and repetitive labor roles, have intensified over the past decade, leaving many SMEs struggling to fill essential shop floor positions. This has coincided with increasing customer demand for high reliability, shorter lead times, and traceability across production processes. Additionally, SMEs often lack internal engineering bandwidth to evaluate, specify, and implement automation. The result is an undeniable hesitation towards the adopting unfamiliar technologies. Examples from real-world operations show manual processes are prone to variability, absenteeism, disruption throughout, and overstretched staff are forced to juggle multiple roles at once. A lack of data-driven processes further compounds these issues, as many SMEs don't have accurate measurements of cycle times, rework rates, or operational bottlenecks. Combined, these factors contribute to stagnation, and it makes scaling operations a significant challenge without external support or process transformation. Historically, the low adoption of robotics and automation in SMEs can be attributed to a combination of financial, technical, cultural barriers. High upfront capital costs, often stretching to six-figure investments, made automations appear financially inaccessible for businesses operating under a tight budget. Compounding this, traditional industrial robots require complex programming and additional infrastructure such as guarding, significant floor space, making it quite impractical for SMEs with smaller facilities. A lack of in-house robotics expertise means that businesses were dependent on integrators, adding to both costs and perceived risk of dependency. A high mix, low volume production environments common in SMEs were poorly suited to early generations of automation, which have required lengthy setups, rigid operating parameters, and quite costly to reconfigure. So fear of return on investment, uncertainty has discouraged leaders from pursuing automation when payback seemed intangible or unpredictable. Moreover, many SMEs fear operational disruption, believing that integrating automation would actually require extended downtime, specialist maintenance capabilities, and all of these factors combine to create a perception that automation was reserved for really larger enterprises rather than a practical tool for small businesses. So what's changing? There are several major shifts that have created a more favorable environment for SME adoption in robotics and automation. Firstly, collaborative robots, or cobots as they're termed, have transformed affordability and safety by allowing fenceless operation and simpler deployment. Their intuitive programming interfaces often involved sort of hand guiding or low-code interfaces to train them. This eliminates the need for specialist programmers. Compact, modular, plug-and-play automation solutions from SMEs now allow SMEs to fit systems into tighter spaces previously unsuitable for the traditional robotics. And the rise of subscription-based financial models, such as leasing and robots as a service, has dramatically reduced the capital expenditure barriers, allowing SMEs to pay for automation as an operational expense rather than a one-time investment. Additionally, labor shortages and rising wage pressures increasingly push businesses towards automation as a necessity rather than a choice. Market expectations have also changed. Larger customers now demand consistent quality, stable throughput, and digital traceability from suppliers. These pressures, combined with support from programs such as the Made Smarter scheme and regional catapult centers, have made the process of evaluating and adopting automation far more accessible than it was before. SMEs today have access to a wide range of pre-engineered automation packages that significantly reduce the integration time and complexity. Pre-engineered welding cells offer modular cart-based systems with intuitive programming suitable for short-run fabrication and high consistency requirements. Examples include cobot-based welders with hand-guided teach models. There are pick-and-place cobot bundles combining grippers and vision systems and software, which make ready-made solutions for handling components, kitting, or doing machine tending. And it kind of removes the guesswork in selecting compatible hardware when you're joining things together. Plug-and-play palletizers represent one of the most SME-friendly options, offering rapid installation, predictability, and throughput improvements, and intuitive multi-recipe configurations for different packaging types. These systems often require minimum training and can be redeployed between production lines with ease. So additionally, the subscription-based automation models let SMEs acquire turnkey cells, complete with maintenance and performance guarantees through monthly fees instead of large capital investments. Collectively, these packaged solutions shift automation from bespoke engineering to predictable, repeatable products that align with SME needs. A strong support ecosystem exists to help the SMEs adopt robotics and automation effectively with reduced risk. National and regional system initiatives such as the Made Smarter scheme provide grant funding, leadership development, digital road mapping, hands-on technical support to qualifying businesses. Technology innovation centres, including the Manufacturing Technology Centre, the MTC, and the Advanced Manufacturing Research Centre, the AMRC, and the WMG, they all offer feasibility studies, simulation, offline programming, and pilot development environments to de-risk investments prior to purchase. Private sector integrators supply, the integrators themselves supply turnkey solutions with installation, training, and ongoing maintenance. Many are now specialized in SME scale deployments, so they'll offer special modular cells, rapid install kits, post-deployment support agreements. And together, these support channels help businesses overcome the knowledge gaps, then validating their own ROI projections and gaining confidence in selecting automation technologies suited to the processes.
So, one more minute, Andrew. Otherwise,
okay. Then basically, we'll run down. So to determine when investing in automation makes sense, SMEs can apply straightforward readiness framework. I'm just going to run through those now. First, any process that is repetitive, high frequency, ergonomically challenging is usually a strong candidate, especially if labor availability is inconsistent. Secondly, processes that act as bottlenecks, limiting throughput or creating scheduling instability, they can yield strong payback. Thirdly, where you need consistent quality or traceability benefit. Fourth, you've got safety risks such as heavy lifting. This is the dirty, dull, and dangerous jobs within the facility. And applying all this criteria, you can try to make sure you've got the right kickoff. And then finally, I would recommend
like 10 minutes, 10 seconds just to summarize.
Yeah, finally, I'd recommend that you basically identify the right processes, come to a facility to validate them, such as a good trusted integrator or a helping body like the MTC, and then just pilot it. Don't jump in at the deep end.
Thank you, Andrew. Much appreciated. There's a nice overview there. Without further ado, Gilbert, are you our second speaker or Ian?
Ian is the second speaker.
That's going to be me next. So do you mind putting the slides up for us, Henry? Okay, so while the slides are coming up, thanks everyone for the opportunity to speak today. What I'm going to do is obviously we've talked a lot there about automation indoor and in factories and that sort of approach. What I'm very much interested in, if you can go to the next slide, please, is the commercialization where we've got robots maybe in a less my first slide's missing, by the way. Autonomy as a service is my key strategy, and what that's basically around is sorry, the slide's not there, doesn't matter. Henry, that's fine. So the key message for me is about autonomy as a service. What is that all about? Well, if you're in a controlled environment like a factory or in indoor, or obviously you can have someone watching the robots, you can have someone nearby the robots, and therefore you can have multiple robots, would have someone sitting there or advising or watching. Once you start getting outside into the outdoor world, onto pavements or onto roads, or watching drones in the sky, you can't have someone walking alongside. You can't have someone sitting in the vehicle as a safety driver. You can't have someone walking along robots in shopping centres and outdoor, because it's not commercially viable. So for me, it's all about the removal of that safety driver, removal of that person watching the drone all the time, removal of that person having to be there alongside robots when they're operating in the sort of public environment or in shopping centres, etc. So what we have here is a number of things that we as Smart City create to try and enable that. Obviously, we're very interested in the connectivity, the 5G infrastructure, making sure that we can get low latency connections and that we are able to monitor remotely and take control and teleoperate if necessary. We are really about autonomy. We're not about teleoperation, but we do have the ability to step in with teleoperation if necessary. So on this screen, you can see there's a little bit of a control room. You can see some different robots that we have down on the left-hand side, which are robots that operate on pavements. This is working with the council. We also have our V2X platform, which is about connecting maybe to traffic lights, to real message signs. We also have, you can see the shuttles on the right-hand side that are running on the streets in Milton Keynes. So as I said, it's all about autonomy as a service. It's all about enabling these robots. And then it's about building these building blocks from connectivity to data platforms, to share data, all the way up through to dashboards and the ability to operate services. Do you want to go to the next slide? Is it another one, Henry? Yeah. Okay. And this is just, again, we are Milton Keynes based. We do work with a number of different places as well. We've got some shuttles running in Solihull, NEC. We've got vehicles down in Suffolk. We run the annual robot competition here. We've recently taken on the Agibot robot portfolio, which is humanoids and dogs. We've got the Capra portfolio, which is about, as I said, surveying and doing things like removing chewing gum, de-icing the pavements, all sorts of different things. So there's a hell of a lot of things going on. What I just want to do is give you a flavour of it. We are a team that want to support and help people implement new capabilities. We work very closely with the council. We're very closely with people like Ringway, who are their service provider. But we've done work at the hospital in terms of robots running around there, and also having AI on the camera head end looking for anomalies. There's all sorts of things we can do. Be delighted to invite you to visit us here and get involved. And if we can help in any way, we would love to. And we are trying to make sure that we can create ongoing commercial services. So we are trying to make sure there is a quick win for us all to get robots doing some real value add in this current marketplace. Is there another slide? Yeah, so all it is, there's my contact information. Happy to talk about it. And we're going to hand over to Gilbert. What I'd say, though, is I've got now 8 MSCs that have come from the Cranfield MSc program over the last 3 years. We've been running the robot competition, and the good news is with Cranfield just next door, we've been able to bring on some of their try before you buy approach, which is to get some of his really good MSc guys working on robots in an environment that we're running. So that's been really helpful to us, and pleasure to hand over to Gilbert.
Thank you, Ian. Gilbert.
Thanks, Ian. So hi, everyone. My name is Gilbert Tang. I'm a senior lecturer in robotics at Cranfield University. I'm also course director for the robotics MSc here at Cranfield. So my presentation today is on robotic adoption. Starts with skills. So basically, I want to emphasize the importance of training and skills in robotics adoption. So next slide, please. I'm assuming that some of you from the audience are not from the robotics industry or automation industry. So typically what I do is to do a bit of a clarification of what a robot is. So my definition of a robot is a reconfigurable machine that can be redesigned, reprogrammed, to work on a different solution, providing a different solution for different application. And robots these days are being used across different areas. So traditionally, robots are being used in places like factories and manufacturing plants as industrial robots. But now we see more and more robots being used across the service industry, both in professional services and personal service robots, so inside domestic areas. And we can even see robots now being used more and more in space. There ever more development looking at space robotics for on-orbit type applications such as assembly and manufacturing and planetary exploration for different planets. What is not robotics or robots are software robot or robotics process automation, where a lot of people get confused, with physical robots, what roboticists actually deem as robots. Okay. So these I think I felt that this is very important to get out of the way at the beginning. And traditionally, next slide, please. Robots are being used to solve the 4Ds. So what are the 4Ds? 4Ds are referring to the dull, dirty, dangerous, and dear. So dull are tasks that are really boring, really time consuming, where we don't want people to do because they are basically taking out the soul of people. And robots are highly effective and very good at doing repetitive and time consuming tasks. And through automating this task, we allow people to be freed and worked on more tasks that require more of their creativity and decision making. And there are also the dirty tasks, where people have to work with unpleasant materials or substances, such as sewage inspection, livestock handling, or forensic work. And these are tasks where we really want to automate and get, isolate people, from these elements. And then there's the dangerous stuff, referring to things like hazardous chemicals, bomb disposals, where we really don't want people to be anywhere near these environment. In this case, we can have robots that are remotely controlled, teleoperated, or even working autonomously to solve some of these problems. And then the last D is dear. So D is referring to the potential cost for not using robotics or automation technology in solving a problem. By not buying the machine today, you are basically losing money in the long term by not automating the some of the problematic processes, which is costing you both productivity and potentially harming your employees' health. So let's have a look at some of the current capabilities in the next slide. So here are some of the more recently deployed capabilities can be found in robotics. So particularly more notable one is collaborative robots, which many of you would have heard about. So these are robots that are designed to work alongside people. They're typically designed to be easy to program, easy to integrate, and easy to deploy for industrial tasks. And that really explain their popularity in the last decade. Another type of really popular robot, more and more being used in the last 5 years, is autonomous mobile robots. So these are typically being used in warehouses and factory for things like material handling, logistics, and inventory handling. And then we have also more powerful machine vision system that are AI power, AI driven now, that can be used for quality inspection, sorting, identification, object tracking, and also even some basic decision making during the validation and assurance of a product. Coding and programming of robotic system are also becoming easier now with graphical user interface that allow programmers to drag and drop blocks into forming a program. There are also hand-guided robots where operators can physically move the robot to certain spots, and then by saving a number of different locations, they can then stitch together a complete routine that allow the robot to perform. So looking forward in the next slide, here are some future capabilities where, following the trajectory of technology development around robotics and some of the complementary technologies, we will be seeing more and more AI-driven robots, using artificial intelligence techniques and technologies such as large language models to help them to give them more adaptation to variability, both in the products that is working with, also in the environments. So robot can be used in a much larger variety of tasks, but also in different situations and environments. We will also see more advanced human-robot collaboration. So at the moment, the human-robot
Would you be able to wrap up in about a minute or so, Gilbert, please?
Pardon?
If you could wrap up in a minute or so,
Yeah,
that'd be
okay.
really helpful, please.
I'll try and speed up a little bit. At the fairly basic level, meaning they are more on a cooperation than collaboration. So in the future, we'll see human and robot integrate more closely together, having multimodal interaction where they share tasks rather than simply coexisting in the same place. We will also see general purpose robot that can be used for multiple tasks without the need for reprogramming. Also, we have digital twin and simulation being more capable of simulating a real environment, and cloud and edge robotics where robots can be monitored and controlled remotely from different locations. Next slide, please. And the key point what I'm trying to bring out is some of the one of the key barriers to robotics and automation adoption is the lack of training and education. And the reason why it matters is because we already have training for essential robotics and fundamental skills such as how do you program a robot and how do you build a robotic system. But there are still a skills gap in for people who are actually taking decision, who are actually able to design this robotic system. So people typically at the executive level who have a poor awareness of what kind of automation or robotics technology that they can implement in their workplace, in their factories or in their plants. If we can train these people to have the awareness of what is the ROI of adopting robotics technology, or what are the sort of improvement that robotics and automation can bring, then we will definitely see an acceleration in adoption. And just want to wrap up my presentation really quickly in the last few slides. Some of the activities that we have.
Like 10 seconds or maybe 15, that would be great.
So next slide, please. So some of the national level educational program that we have been involved in recently are the level 6 and level 7 degree apprenticeship standards. So we were academic leads for writing this standard, which led to the first robotics engineer apprenticeship in this slide, offered by the MKU for developing skills for innovation. We also have the master in robotics in the next slide. Next slide, please. Where we train people with a high level of skills who are able to design, develop, and deploy robots into the real world, from scratch when they're given a problem. So if you have any questions about this, my contact details are at the bottom of the slide, and these slides will be shared with the audience as well. Thank you very much.
Thank you, Gilbert. Thank you, Andrew. Thank you, Ian, for 3 very interesting presentations with different perspectives of the world of robotics, not least the training and apprenticeship and right up to MSc level and academic collaboration, about autonomous vehicles and a wide application of robots in unconfined spaces. And then I guess a bit more the sort of traditional robot arm kind of thing in manufacturing plants and warehouses and the like that. So I'm going to open the floor for some questions. I don't know, I just give opportunity as well if Freddie, Henry, or Axel have burning questions at this stage. Otherwise, the floor is open.
I could probably start with a question for Gilbert there. Thank you, Gilbert. I mean, just based on the fact that you obviously got your finger on the pulse of what's coming up in the future. You put some slides in there about new technologies where robotics are say taking commands from large language models and becoming even more easy to integrate into manufacturing environments. What sort of time horizons do you have on that? When will it become a reality that we can deploy a
Actually, that's something that we have already been working on for the last 3 years, ever since we have the first ChatGPT model, and we have successfully been able to integrate large language models with humanoid, so that we can actually command. Well, we can tell the humanoid verbally what we want them to do, and that translates to executable code and command for the robot to execute. So we can say to a humanoid, can you walk forward by 2 meters and then turn right and then walk another 2 meters. It can actually translate that into code and execute that and do that in real life. So
yeah, I
to
mean,
see that being deployed in real application, I would say we can probably see that in 2 to 3 years, in the next 2 to 3 years.
3 years, yeah, because I mean that obviously really does break down the barriers for SMEs and all organizations really to to overcome those difficulties of having to hire a programmer or having an integrator design something very rigid. You've got true general purpose robots, which of course makes life a lot easier for all businesses.
Absolutely, and we also see a evolution in our students as well, in the way they work and the quality they program, by using large language models and AI tools that are available to them these days. They are capable of writing very sophisticated robot program in a much shorter, amount of time
So
through
we
some
have
of
an
the
important
projects.
fusion we are encroaching on here between the world of AI, or specifically large language models, and the programmability of various kinds of robots, which is clearly a direction of travel. From the audience, would you like to chip in any questions? More than welcome.
I've got one, Ben, to I think everybody is obviously when robots first came out, they were sort of guarded away and did very specialized things. And then we got cobots, which kind of reacted a bit more with people. The big focus now, as well as sort of autonomous vehicles, is humanoid and animal-like robots. Is that not just a diversion? Because for most tasks, you want something that's specialized to a particular task. So it doesn't make sense to have something with legs when you can have it, stationary or with wheels. Where do you see all this going? Do we really need, things that look like humans or dogs, or are we better off having something specialized for each particular task that avoids all the complexities that having limbs and everything makes?
Well, I think, if I can answer it, I personally think that there's a role for the dogs. There's a role for the different outdoor robots of different shapes and form factors. And, clearly it is about what is the end application. Ideally, though, you want to have some sort of platform that you can adapt and add capabilities onto. I think there's a role for the dogs. I mean, I was at United Utilities yesterday and we had probably 6 or 7 different dogs on display from different organizations that do different tasks in the utility sector about, surveillance or research or inspections or different things. They all came with a basic capability, either legs or wheels, and then they had a payload and they were able to do things. There are different shape sizes. I think there is going to be a need to get the right robot for the right job. I also think humanoids, as Gilbert was saying, we've got a number of humanoids now. We were at a presentation 2 weeks ago at ARM. We had nearly 1,000 people in the audience, and we had all the robots programmed up, and they interacted with the ARM organization on all sorts of questions and queries, and it was just brilliant. It was honestly, it was brilliant in terms of the questions they were asked and how they responded. We also did some fun things like getting them dancing in unison and stuff like that. But really, they were really, really good as interactive robots to that audience. So I think the form factor of the robot, obviously I look at things from a commercial viability point of view. I want to have a form factor of a robot that I can use and adapt. And the thing about it is, it's not necessarily just the form factor; it's also that the data set is local. I have all my information here locally in the UK. That doesn't go anywhere else. I can then program it up and manage it and interact with it and create the right interfaces through the APIs in the UK rather than having it go anywhere abroad. So I think there's a few things, but the form factor might vary. I mean, others, Gilbert may have a different view, but my view is, you will need the right form factor for the service you're trying to deliver, but I don't think it matters whether it's got legs or wheels. I mean, they're a lot more stable now. In the old days, a humanoid wasn't very stable, right? But they're getting much more stable.
Balance is everything. Mike has a question.
Yeah, I think it's just an observation on Henry's question, really. The robots evolved, specialist units, very difficult to prove the return on investment for a small, medium enterprise company having to specialize and customize a robot. And I think the industry push, and Gilbert, you can correct me on this, but the industry push is for much more generic form factors that are much cheaper to commercialize and specialize. Hence, return on investment for a small, medium enterprise is much more viable. So I think that's a trend in the industry that we're seeing that will help ultimately SMEs with their adoption.
Would you like to come back to that, Gilbert?
Yeah, Gilbert first. Yeah.
Andrew, any of you? Start with Gilbert because he was mentioned.
Yeah, that's. I think that answered both questions. I think that's one of the key motivation for the development of humanoid is having this general purpose platform. That are trained on large data that allows the robot to be able to reason and to adapt to a large variety of environments and working on different tasks, so that in the future we can deploy this robot on most tasks. Without having to reprogram them or train them significantly, or maybe we can just verbally tell the robot, what to do or what we want them to do, or what's the expectation in order for the robot to begin working. And I think that would greatly reduce the training requirement on the people.
Andrew, do you want?
Yeah, my thoughts are, I mean, I'm very much behind the humanoid form factor. I think the world was designed for humans, and this is one of the arguments that's often used. It says, well, everything from door handles at certain heights or confined spaces, even in a factory, they're designed around a human being able to maneuver around the factory between benches and things like that. So I think the humanoid form factor will win out in the long run. I think there's a little distraction with sort of dancing robots and dogs and things like that at the moment, that I think it's seen as a little bit of a parlor trick, really, and there's still quite a bit of work to do before we can actually deploy them, in the factory and then maybe ultimately in the home for care work and things like that. They're here to come. Sure.
Can I just add one thing on that? All I'd say is that the ones that are coming to me mostly at the moment are for the dogs and for the ones that do a little bit of entertainment. And it's mainly because if you're an SME, especially if you're in the entertainment industry, or you want to attract more people to your business, and anything that's doing a little bit extra is quite interesting. And that's where I feel, they're quick wins. It doesn't take too much to be able to get a robot to do a few tricks. I mean, a dog or whatever. So there is this sort of entry level, interesting point. The dog's obviously stable. It can do a few things. It can attract more people to your business. So yeah, I'm not saying it's going to solve the world with the dog. I mean, obviously you've seen the dogs going out and doing some deliveries in Milton Keynes recently. Our biggest thing is working with the council about licensing for robots on the pavements. That's a big project that we've got. And as I said, the de-icing and everything, and we've got the dogs out there. I'm doing so many miles a day with the dogs on the pavements. The big thing is that someone's going to walk alongside the dog at the moment. But once I get it licensed that it can run on its own, that's when it gets interesting. Yeah.
Very good point in there. And I've seen online, because I'm not directly involved with the world of robotics. In fact, I saw a real one. It was more or less a bit like an octopus tentacle and fish and all different things, arachnoids and the like. Changing topic a little bit. I work in the world of satcoms, and people are looking at robots in space for dealing with space debris, for example. whether you send up a satellite in a robot arm and it flings satellite down, it deorbits. Satellites, I think, in Gilbert, your presentation, you showed a Mars rover, and there are other examples around. But also robots can be used for surgery. And I've heard of someone who's going to have surgery quite soon, some serious surgery, and that's going to be done via robot. And I've also heard of robots being used remotely for surgery, so the other side of the world. So what I'm trying to lead up to here is that to communicate with a robot that is not local takes time, latency for the signal to get there, whether it's in space or around the world. And I'm not sure how I'd feel if someone was having heart surgery with a robot controlled by someone on the other side of the world, knowing that to make a correction is going to take a few hundred milliseconds. So with that in mind, is latency an issue, and is communications to these robots, wherever they might be, an issue in terms of latency and resilience? If any of the panel would like to comment on that.
So this is a key thing for us. I mean, obviously, because of the autonomous vehicles and the robots on the pavements, and because the fact that we're, commercial viability only comes from removing that safety driver or the person walking alongside the robot, having that 5G network connectivity and low latency is critical. Now, it's not critical for the actual robot or the vehicle to work autonomously on its own, but what it is critical for is should we want to do a command, or should we want to see where they are, should we want to see what's happening or take control, then we need that connectivity. And Milton Keynes, we're fortunate, we've got our own 5G standalone network here in MK that we've built ourselves. We've also got BT kindly upgraded their 5G network to a 5G standalone model, and we've got access to that 5G standalone from BT as well. I don't think we've currently got all the necessary network slicing access that we need, but eventually that will come. So what I would say is, I'm talking about the outside world. I'm not talking about an indoor, network. You may have the best low latency network between your sites, and maybe you could do something over your own private network between hospitals that could be doing something. So I don't know how quick and how low latency that would be, because it's but I'm more worried about external, outside world 5G networks and things. And on that scenario, we're looking at trying to get under 40 milliseconds. And if you can keep the latency consistent, then you can teleoperate the vehicle, and it's pretty good. I mean, obviously at 40 milliseconds, you're not going to notice it. But you start getting up to half a second, 400 milliseconds, then you start having a bit of a lag between what you're
for your applications.
Yeah, for our application. So I mean, I'm not a person who I'll let the people who do the surgery talk about it themselves. But yeah, for our applications, we're talking about monitoring the vehicle, monitoring the passengers, monitoring what's happening around them, and then being able to take control if necessary.
Thank you. And Andrew, you might have a view, because your presentation seemed to me to focus on factory environments a bit more. And even if the communication doesn't have to go very far, if something in a factory environment is happening quickly, you need that signal to get there much quicker than 40 milliseconds.
I think that would be key. I think people will be looking for things to be done locally, live. I mean, that is the beauty of actually having onboard computers built into the robots with vision systems, so they can look at their own environment and make on the fly decisions. So there is no kind of network in the process or anything like that, because network can drop out. I've had difficulties connecting to this webinar just now. You don't want to be relying on that in critical situations, and industry is all about repeatability, guaranteeing the same thing all the time, and uptime is very important. So it's really going to work against robotics adoption in general if there is sort of flaky communication.
Just 1 second, Freddie. Gilbert, would you like to make a comment? You don't have to.
Yeah, just sort of echo Andrew's and Ian's comment that it is a problem, particularly for outdoor robotics, where robots are working in potentially GPS denied environment, or if they are teleoperated, do they have the autonomous capability to operate on their own, when they have a signal loss, for example. And this is a big area of research at the moment for particularly aerial robotics, where they can often be exposed to this kind of problem. For surgical robots, as far as I know, most of them those that are being used in proximity are cables driven. So there's usually an Ethernet cable connecting between the robot and the surgeon on it.
Yes, they are experimenting with it with around the world. It literally could be the surgeon, for example, is in London, and the robot operator is, I don't know, Australia or something, and the latency is a big deal. So it's finding a model-driven robot at a remote point, but being overseen by the surgeon, for instance, in London.
And also applying the appropriate safety protocol, for if there's a signal loss, what does a robot do in this case? Does it just stop
Also
on the
resilience,
spot, or does it move away? Yeah.
Resilience for human safety, for safety of the environment, for road safety, pavements, whatever. Absolutely. Freddie.
Yes, I was just thinking about the commercialization aspect that Ian was talking about earlier on. Now, the key thing that I'm really trying to understand is how far or how close we are to really getting a critical level of adoption in this country. What is happening in some of the Far Eastern countries seems to be somewhere ahead of us. So could the panel perhaps talk about some examples they've seen? You talked about robotics, somebody talked about robotics as a service, or what are there any more examples of robots being commercialized, not in non-military applications, where it's actually beginning to provide some commercial traction? Have you come across this in your travels or in your experience?
Well,
sorry, Ian. Yeah, go ahead.
Should I go for? I'll just go with autonomous vehicles and other things. I mean, at the end of the day, I'm pretty sure you might be aware, Freddie, or not. But the CAV services, as you know, robo-taxis are now being trialed in London. We are just as advanced in Europe as anywhere else. I think you'll find. I mean, in the US is slightly ahead in terms of them deploying robo-taxis and things. I'm actually sure that robo-taxis is strongly beneficial for us all, because I mean, obviously, I think public services and buses is more important. Therefore, I feel the shuttles is a better solution than robo-taxis. But anyway, the technology from the robo-taxis is being tested and deployed in the UK, in London, and then at some point the government will give the license to allow them to remove the safety driver and operate. And I don't think that's that far away. So I wouldn't say on the CAV side that we're that far away. There are a number of trials of buses with obviously that have been adapted with CAV services on, and they exist. I think when you get to the pavements, I mean, we've got the Capra robot over here. I don't think they're being used very, very much anywhere else. I think the delivery robots, the Starship, were just as advanced as anybody else in terms of Starships doing deliveries on the pavements. So I think on the outside, on the outdoor, in the public realm, in those types of things, I think we're quite advanced. I think when you talk about robots in factories, then obviously there may be more advanced places, and the humanoids are coming through now, but a lot of them are coming through from China, obviously. And the thing about it for me is to get hold of them and use them, but make sure that we can control them, we can access the API, we keep the data here in the UK, and we create a service which is valuable to our UK customers, that is not restricted in any way, and that we can develop on it. So that's what I would say personally. But I think we're quite ahead on the autonomous vehicles and stuff.
There's time for maybe just one more question from the audience. If anyone would like to make a comment or chip in. Not at the moment. If you do, we may just be able to...
I can just answer to that while we're waiting then, Ben.
Yes.
The only examples I would give, particularly from, there are SMEs who are finding that labour shortages is what's driving them to onboard the technology. And there's one, I can't give specifics obviously, but there's one client that is struggling to find welders in the where they happen to be situated in the country, and you just can't get the skills. So they're finding that they actually need to turn to robotic solutions, and also finding when they do have a welder, then it's more beneficial for them to kind of step up and manage the welding process because they know what a welder is. So there's this whole kind of human-centric robotics adoption as well, which is quite interesting, where we can actually sort of retain the skills within the business, but just improve productivity by allowing them to supervise, say, a range of cobot welders or something like that. So that's a comforting thought at least.
So it would be interesting if any of you on the line feel like it, to make a comment in the chat, if you can access the chat, in relation to robots in general. And if you think it's a pipe dream and it's a nah, just write pipe dream. If you think it's great and it's coming or it's already here, then you might want to write something like bring it on. It'll be interesting to sort of gather some wide views. We've covered a number of topics, the communications and latency, AI, a whole range of applications of robots, and there are many, many more which we haven't talked about. So they're very important in nuclear decommissioning, for example, and other areas. We've talked about what a robot might look like and what a robot is. But I don't know if there's some closing comments from any of the panel members, just sort of 10, 15 seconds each.
I can give you a quick punt from my side, which is Smart City. Obviously, please get out on the shuttles. If you haven't been on the shuttles, they're running around the city centre. We do have a safety driver on board at the moment because that's what we have to. But you can book on the shuttle and run around, which will be great. And if you haven't been at the Experience Centre, come and visit some of the robots and have a look at what we have got. Thanks for the opportunity.
Andrew, quick 10, 15 seconds max.
Yeah, say if you have got an interest, then seek out the things like Made Smarter, and they can do match funding up to £20,000 on a capex project. So if it's linked to digital, so that's a good way in, and then you can always come and get impartial, free of charge advice from the MTC as well.
Gilbert.
Yeah, so I just want to make a quick comment on the fact that when we look at robotics adoption, when we look at UK robotics adoption versus the international robotics adoption, we are actually behind. We're diverting from the international trend. And one of the key barrier and reason for that is the lack of skills. So lack of awareness and training for people who are in charge of making those decisions, but also people who will be developing and deploying those robots. So for any interest in training and education, feel free to contact me, and I'm very happy to discuss some of the options.
Ian, Gilbert, Andrew, and the audience, thank you for what you've brought, and hopefully it's been interesting. We have some interesting discussions and interesting presentations. Freddie, over to you for perhaps a few closing comments.
Well, I just want to say a very big thank you to all of you for joining us today for this session on adoption of robotics for SMEs. A big thank you to our expert panel again for sharing their experience and their insights. I found it very, very insightful to see some of the examples that you put on the table today. And it's really also helped to highlight the potential and the opportunities that can come from us becoming more knowledgeable about what's possible with robotics. So this is a conversation that I think we've only just started. Biztech, our ambition is to bring this kind of knowledge and community together, where we're constantly learning and really helping one another to see opportunities to grow our businesses through better knowledge and through collaboration, and hopefully strengthen resilience in our area, resilience of our businesses for the long term. So Biztech, we want to help us all to stay connected. I would like to give you more information about our upcoming events, but probably the best thing to do is to subscribe to our newsletter if you don't already. We will be expecting to do another event in the next 4 to 6 weeks. So please, if you're not on the newsletter, do register, and we'll be keeping you up to date as what's happening. Thank you all once again for joining us today. It's been a pleasure to welcome you, and we look forward to staying connected with you in the future. Thank you all. Have a good day.